On a clear night, when the stars shine brightly overhead, we can see thousands of tiny lights scattered across the sky. But those few thousand stars are only a fraction of what's truly out there. Our galaxy alone contains hundreds of billions of stars, and beyond it, countless other galaxies stretch into infinity. For centuries, humans have looked upward and wondered, are we alone? Are we the only form of life to emerge in this vast universe? Or are there other alien civilizations watching the stars as we do? This question is more than curiosity. It cuts to the heart of who we are. If we are alone, life on Earth may be unique and fragile, a one-time miracle in a cold and empty cosmos. But if aliens exist, whether simple microbes or advanced civilizations, it means the universe is not silent, not empty, but alive with possibilities. Tonight, we explore the evidence, the theories, and the mysteries that surround one of humanity's greatest questions, the existence of extraterrestrial life. To even begin asking about aliens, we must understand the sheer scale of the universe. Our home Earth is just one planet orbiting a single star, the Sun, but the Sun is only one of more than 100 billion stars in the Milky Way galaxy, and the Milky Way itself is one galaxy among at least 2 trillion in the observable universe. Numbers this large are almost impossible to grasp. Imagine standing on a beach. Each grain of sand is tiny, yet together they form miles of shoreline. Now, imagine that each grain of sand represents a star. The number of stars in the universe exceeds all the grains of sand on every beach of Earth combined. Around many of these stars, planets orbit. We once thought planets were rare, but modern astronomy has revealed that they are common, perhaps more common than stars themselves. In the last 3 decades, astronomers have discovered thousands of exoplanets, some of them similar in size and distance from their stars to Earth. When you realize that there may be billions of Earth-like worlds in our galaxy alone, the idea of alien life suddenly feels less like science fiction and more like a statistical certainty. In 1961, astronomer Frank Drake introduced a way to estimate how many civilizations might exist in our galaxy. His formula, known as the Drake equation, multiplied together several factors: the rate of star formation, the fraction of stars with planets, the number of planets suitable for life, the likelihood that life emerges, the chance that life becomes intelligent, and the probability that such civilizations develop technology to communicate. The equation does not give us a single answer, but a range. If life is rare, the number may be close to 0. But if life is common, the galaxy could be buzzing with intelligent civilizations. The Drake equation shows us the possibilities and highlights how much we still don't know. Every discovery of a new planet, every advancement in biology, every mission to Mars slowly refines these numbers. And as those numbers shift, so too does our estimate of whether aliens might exist. When we imagine aliens, we often picture humanoid beings, creatures with eyes, arms, and intelligence. But perhaps the first aliens we discover will be much simpler. Life on Earth began with microbes, tiny organisms that lived in the oceans. Billions of years ago, they were small, fragile, and invisible to the naked eye. Yet they changed the planet, producing oxygen and paving the way for plants, animals, and eventually humans. What's remarkable is how tough life can be. We've found microbes that thrive in boiling hot springs, inside glaciers, deep beneath the ocean floor, and even in radioactive waste. These extremophiles show us that life can adapt to environments once thought impossible. If life can survive in these extremes on Earth, why couldn't it survive on other planets, under alien suns or beneath icy crusts? The rules of biology suggest that life doesn't need perfect Earth-like conditions. It only needs chemistry, energy, and time. Mars is our closest neighbor in the search for alien life. Today it appears barren, dry, cold, and dusty. But billions of years ago, Mars was different. It had flowing rivers, vast lakes, and perhaps even an ocean. Its atmosphere was thicker, and its climate more hospitable. Rovers have discovered ancient riverbeds, minerals formed in water, and chemical compounds that hint at the building blocks of life. If Mars once hosted life, even if only microbial, traces of it may remain locked within its rocks or underground. Finding life on Mars would change everything. It would mean that life is not unique to Earth. If it happened twice in the same solar system, then it must be happening countless times across the cosmos. While Mars captures much attention, some of the most promising places for alien life are far beyond it. Moons like Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, are icy on the surface but hide vast oceans beneath. Europa's subsurface ocean may be twice the volume of all the oceans on Earth. Enceladus shoots plumes of water vapor into space, laced with organic molecules, the ingredients for life. If these oceans have heat from volcanic activity on the sea floor, they could sustain ecosystems much like Earth's deep-sea vents, where sunlight never reaches, but life flourishes in abundance. These ocean worlds remind us that life does not necessarily need a planet like Earth. It might thrive beneath ice, hidden in places we can barely imagine. For decades, reports of unidentified flying, objects now often called unidentified aerial phenomena, have stirred curiosity and controversy. From strange lights in the sky to objects tracked by military radar, these sightings spark questions. Most turn out to be natural phenomena, experimental aircraft, or illusions, but a small fraction remain unexplained. Governments once dismissed them, but today, official investigations acknowledge the unknown. Does this mean aliens are visiting Earth? Not necessarily, but the mystery of UFOs reflects our desire to connect the unknown in the sky with the possibility of life beyond. While some look to the skies for visitors, Others listen for voices. The search for extraterrestrial intelligence, or SETI, scans the heavens with giant radio telescopes, searching for signals that might come from alien civilizations. So far, no confirmed signal has been found. The silence may be temporary or permanent, but each new technology allows us to search deeper, across more frequencies, and in more of the sky. If we ever detect even a single artificial signal from the stars, it would mean that we are not alone, that someone else, somewhere has built technology, asked questions, and reached out. With so many stars, planets, and possibilities, one puzzle remains. If life is common, why haven't we found it? This is the Fermi paradox. One answer is that civilizations may rise and fall quickly, destroying themselves before they can spread. Another is that advanced beings may avoid us, choosing not to interfere. Or perhaps the distances are simply too vast and the signals too faint for us to notice. The paradox reminds us that while life may be common, communication and contact could still be rare. The search for alien life is far from over. Telescopes like the James Webb are already scanning distant exoplanets for chemical signatures of life in their atmospheres. Upcoming missions will visit Europa and Enceladus, sampling their plumes for signs of biology. And in the decades to come, humans may set foot on Mars, carrying instruments capable of answering the question once and for all. Each mission, each discovery brings us closer. Whether we find microbes beneath Martian soil, ecosystems under icy moons, or signals from distant stars, the result will reshape humanity's understanding of its place in the universe.